solution for Ethereum that brings privacy and scale. It ensures the input, contract state, and the execution are always encrypted. Today, he will present T-based rollup, the sweet spot between optimistic and ZK rollup. So let's welcome him.
Thank you. So good evening. My name is Jobin. I'm a developer relations engineer at Obscuro. I'm here to talk about TEE-based rollups. Just a second. I want to capture you all, so I missed starting to record this. Yes. Yeah. So, I know that all of you are here because you know what Ethereum is. Is anybody here who doesn't know what Ethereum is? I hope that everybody knows what Ethereum is. Okay, so Ethereum is a layer 1, L1, okay, and a lot of L2s have been coming up, which is there to solve multiple problems. Ethereum has got a bunch of problems, which it is trying to solve. And I hope in the long run it will achieve some of them. But at this current moment, a lot of rollups, a lot of L2 layer 2 solutions are trying to provide solution to these problems. Okay, so I'm going to talk about TEE-based rollups or confidential rollups, which sits between a sweet spot between optimistic rollups and ZK rollups. I hope that everybody is aware of optimistic rollups and ZK rollups. Okay, so yes. So what is TEE-based rollups? So TEE stands for Trusted Execution Environment. Okay, so I believe most of you guys have iPhone in your hands. Okay, you guys are using iPhone, and iPhone has got a T1 chip. Why is an iPhone having a T1 chip? It's to execute some critical, some very highly confidential information on your iPhone without that data getting leaked. Okay, so it is an isolated environment. It's a safe environment. It's like a box which is locked and nobody has access. And inside that box, all your critical, highly confidential information is being executed. And in the same manner, TEEs or trusted execution environments are small isolated boxes or environments in your computer chipset, which allows you to do execution or do computational activity on your data, highly confidential data, without that getting leaked. Your MacBooks have, your Windows laptops have, your computers have, every. AMD has got SEV, Intel has got SGX, then there is ARM has got Trustzone, then Apple has got T1 chips, which allow to do this execution very safely in an isolated environment. Okay. Then what? Why? Why are we talking? Why are we having this session? Why are we doing this session on scalability, privacy, affordability on Ethereum? Why? Because Ethereum has got all these problems. I'll take you through a bunch of problems that Ethereum has. First is scalability. From day one itself, Ethereum, when developers started using Ethereum, started building dApps, deploying smart contracts, when the number of dApps and smart contract soared high, we started facing the problem of scalability. Now there is limited bandwidth on what you can do on Ethereum. Okay, this results in what? Network congestion. Ethereum has very high network congestion because of the scalability problem. Next, what? This is one of the very high critical, that's why I have put in the center part of the slide. Ethereum has got this privacy issue. It's a major issue that whenever you store anything on Ethereum, your NFTs, your ENS details, whatever data you store on Ethereum or blockchain is public basically. So we say that we have privacy and transparency at the same time. But isn't that an oxymoron? totally opposite things. Transparency and privacy both are opposite things. So Ethereum, by its virtue, is a transparent blockchain. So whatever you do on Ethereum is public. Your name or your contract details, everything, literally, whatever you inputs, your contract state, your execution, everything is literally transparent. Anybody can see. So where is privacy? I don't see privacy. I can't see privacy. And if we go out and start checking out, how many of you have checked out ETHScan after doing a transaction? Most of you might have tried. And you might have observed, right? What if you have a transaction hash of somebody else's transaction, you can basically see what input they have given. That's a flaw. Consider I am buying an health insurance and I'm putting my diseases, my blood type, my address, my all details, my personal details, only which maybe I know, onto a health insurance smart contract, and somebody randomly can come and open the smart contract, the contract address, and see my personal details. Isn't that a threat? Isn't that a problem? Somebody else knowing what is your personal data? That's a threat. That's because Ethereum lacks privacy. And this is one of the biggest disadvantages, and that is why we are not seeing Ethereum being used in a large scale in institutional applications and softwares. Ethereum is used in a lot of community-based projects and apps. Have you seen Ethereum being used widely in institutional-based softwares and applications? Very rare. There are a bunch of them, but very rare, where there is no need for privacy. That's where it has been used. You can't use. So next what? Because of this problem, because of the scalability issue, and because of this network congestion, the cost of doing anything on Ethereum is literally super, super high. It's more, I came to Taiwan yesterday, and literally with the cost of doing a transaction on Ethereum, I can travel in the MRT multiple times. How costly is that? You're barely storing information on Ethereum, and it costs you multiple, the total amount of traveling multiple times on MRT. It's very high. And during the DeFi boom, when DeFi was booming, when a lot of people were doing a lot of financial transactions on Ethereum, the price of a single transaction on Ethereum went up till $60 to $70. That's super high. I would basically buy a bunch of Nintendo Switch games from Taiwan back to home with this money, rather than doing an Ethereum transaction. So that's where the statement that Ethereum is a public blockchain for the masses goes down. It's not for masses. It's only for the rich people, techie people. I'm being a bit brutal, but sorry. But that's actually a problem. It's because everybody is using, and we are in an early stage of blockchain. Okay. But we have a solution for that. We have a bunch of solutions which are trying to solve all these problems. But I'm going to talk about mainly focusing on this problem, the privacy problem. But at the same time, we are ensuring that the scalability and cost problem also is solved, but the focus is on privacy. Okay. Just a second. And if anybody of you don't think that privacy is a critical problem, then I'll take you back to an incident that happened a bunch of years back. From the Walmart website, a teenage girl was ordering a bunch of things because she was approaching her pregnancy. And that same account was being used by her grandpa. And because she was ordering all these products, her family didn't know she was pregnant, but Walmart sent recommendations to her grandpa, and her grandpa got to know that she was pregnant. Why? Because there was lack of privacy. Your data is no more your data. Companies are stealing your data. They are misusing it. They are using it to target advertisements to each one of you. So you are getting advertisements based on what you search, what you see, what you hear. Literally, every data that you create on internet, on mobile phone, or your smart devices is being used against you as a weapon to pursue you to buy different products and services. That's a big risk to your privacy. So the next thing. So what the current, I'll take you to, I'm not sure I believe that there are a lot of geeky, nerdy guys sitting here, but I want to even include a bunch of guys who are not that geeky, not technical, and show them what Ethereum looks like. So Ethereum, right, I'll take an example of a building. This is a one-story building, and this is the ground floor, okay? And this is how the Ethereum looks like. There's a door, and the walls are transparent. This is Ethereum. This is a one-story building. So what the problem is, so whatever is happening inside your house or your building, anybody can see that. Is that a good thing? You're doing some personal thing in your house or in your building, and the passing by guys being able to see what you're doing inside your house, that's a risk. That's the breach of privacy. So you can basically see whatever your contract state in Ethereum is, because Ethereum is transparent. Next thing, the door is open. So whatever is going inside your Ethereum block, your inputs, that basically is transparent, that's public. So whatever is going inside, even that is public. So basically, who is coming to your Ethereum house, anybody can notice, anybody knows. Okay, the next thing. So whatever execution you are doing, whatever activity you are doing, when that's public, that's transparent. This is the problem with Ethereum. Then what happens when you start doing this inputs, start giving more and more inputs, you start doing more and more transactions, then there is a stop sign that shows there is a network congestion. Okay, so when more and more inputs are given, more and more transactions happen because of the limited bandwidth on Ethereum, there is a network congestion. That is not good, right? Like it's like you want to travel to some station, some place in Taiwan, and the MRT has a long queue. It's a bad experience, right? There's the same experience with Ethereum. Okay, so what do? You might have observed in certain places, you can cut the queue and go forward if you pay more money. That is why I said Ethereum is not for the masses, but for the rich people. Because if you are ready to pay more money, then you can cut the queue and go forward and get your transaction executed. That is a problem. You have a separate queue, like you can escalate or prioritize your whatever the transaction is by paying more money. Okay, then here, that's where the money thing comes, and the cost goes up. Okay, so this is a problem. This is a very high critical problem. Transparency, scalability, cost. I've shown you all three. Next, so what we are doing. So we have a bunch of current solution at this moment. There are two approaches to solving this. Solving the scalability, cost, and somewhat privacy. The first approach of solving that is we try to improve the layer 1 itself by building better node infrastructure. But that's going to cost you more. Okay? The cost of infrastructure, when you set up more infrastructure on your L1, the cost goes high. Then again the same thing for the rich people. We don't want that to happen. Then the second approach is moving all your computationally heavy transactions away from the layer 1 onto a layer 2. And that's where we have two options, ZK rollups and optimistic rollups. These are the two approaches that allow you to take transaction away from the layer 1 and easily do transactions on Ethereum. And somewhat solve scalability, privacy, and cost issue, but not in a very good manner. Okay, and zero knowledge allows you to do, enables you to do lightweight verification. Remember, lightweight verification. If there is anybody who thinks that zero knowledge allows you to do heavyweight verification, that's not true. It only allows you to do lightweight, because zero knowledge uses cryptography, and cryptographic activity on computer is super expensive. Okay, and then there is optimistic rollups, L2 transactions, but the problem is that sometimes a bunch of things are centralized in optimistic rollups. Okay, then coming to the next slide. So what solution we have for this? Okay, and that's where what I did is I built a second floor on my house. I expanded my building. I extended my building. So we right now have 2 floors. It's exactly like your house. Your house has only you and your wife, or you and your husband. That's okay. When you have 2 more children, what do? You build a floor on top of it. so that you can scale. As your needs increase, as your demand increase, you expand. That's why you've built a second floor, a second story. And this basically is a layer 1. This basically is a layer 2. Now you can see, this is transparent. Whatever enters here, people can see. So we have solved that. How? Now it is not transparent. It is opaque. The doors are tunneled. So basically what happens is, in the layer 2 that we have built, we get scalability. Whatever the inputs go inside, that is completely hidden, obscured. So nobody can see inputs. And whatever execution and the contract state is inside the layer 2, nobody can see that also. So basically all three problems are solved. Scalability problem is solved. Nobody can see your inputs, execution, contract state. So the privacy problem is solved. And because there is no transparency, you can avoid escalating your transactions or prioritizing your transactions by paying more money. And now you might be thinking, how is this possible? What abracadabra have we done? What magical spell we have done? What magic is this? So I'll show you what magic is this. I'm unboxing it. So this is the magic. This is the magic. We have unboxed it. What we have inside is called as TEE, Trusted Execution Environment. So in Trusted Execution Environment, you can pass input, you can do execution, and whatever the state is, everything stays within this. Nothing gets out. So you have a safe, secure, isolated execution environment. Now it's like your secret bedroom. Now what you do, whatever you wish you do inside your bedroom, nobody will get to know about this. Okay? So we have built this is our living room, our kitchen, everything is here, and our bedroom is here. So nobody knows whatever you do in the bedroom. Okay? Then, so we are using trusted execution environment for this. And what this allows, what this means to you, this means that now we can scale with privacy, affordably, and effortlessly. Why effortlessly? There are a bunch of solutions that allow you to do TE-based rollups, but the problem is that it's not based on Ethereum. So if something is not based on Ethereum, then what you have to do? You have to go learn a new language, get to know how their SDK works, go through their documentation. Why? We have such a very well-established Ethereum layer 1 blockchain. Just use that and easily migrate or port whatever smart contracts you have to this TE-based rollup, the layer 2. Okay. Then, why TEs? So people, lot of people, now this hype has grown a lot about ZKPs, zero knowledge proofs. But if you dive deep and study more about ZKPs, that's when you will understand ZKPs are not actually meant for privacy. ZKPs are actually meant for scalability. Okay, so because in ZKPs, one of the entity gets to know the information. Okay, you don't actually reveal your secrets, but one of the entity gets to know the information. That's not the person. Okay, so ZKPs are meant for scalability, and the ZKPs, how many of you have seen, you might have observed ZKPs are always, whenever there comes a combination ZKPs for privacy, that's mostly for what? Transactional privacy. Right? ZKPs are mostly used on the DeFi side. They're telling you can provide transactional privacy with ZKPs. But we are not here for just transactional privacy. It's like exactly like Bitcoin. We were not just here for transparent, open, privacy-focused financial system, but we are here for what? We are here for a generalized, programmable, transparent, open, privacy-focused blockchain. That's why TEs allow you generalized programmable privacy. So basically, you can program anything on TEE with complete privacy, not just transaction. So like I said, health insurance, your personal data, your social media, all that can't be made private with ZKPs, but that can be made private with TEEs. Okay. Next. Now you will ask me, I get this bunch of questions. So I got this prepared on what ZKP versus TEE means. So when you are building something on TEE, you can build anything on TEE without extra developer effort. So it's very developer friendly. But in ZKPs, you might have, if you have read about ZKPs, you might have observed that ZKPs require you to make unique ZK circuits for specific use cases. you want to build this A, B, C, D, whatever the specific use case is, then you will have to create your own unique ZK circuit. That means that's an extra effort for developer. But with TEEs, no, basically just write a smart contract that you're writing on Ethereum using Solidity, and that's it, done. The next, TEEs provide you a secure, isolated execution environment without any cost, because I told you, your smartphone, your laptop, your MacBook, everything is a TEE. So basically you can easily do isolated execution of your smart contracts without extra money. But when it comes to ZKPs, it's very cost heavy. If you want to do cryptographic computation using ZKPs, it's very complex and it requires heavy computation, which is very expensive. Then what? TEEs can take heavy, high load computational work, but ZKPs can't, and ZKPs are also not flexible in terms of complex inputs. If you give complex data inputs, ZKPs can't take that. And finally, in the TEE, there comes a questions. There are a bunch of TEEs which have some vulnerability and exploits, but basically that are being patched day by day, and that basically doesn't affect the smart contract execution. And this is very important point. Okay, this is very important point where that small pinch of centralization comes to ZKP. Okay, ZKPs have a small angle of centralization because ZKP circuits rely on semi-trusted sequencer parties for verification. Okay, these are the bunch of things which is TE versus ZKP. So rather than riding on the ZKP hype wave, just go and dive deep and try to understand what actually is ZKP made for. I'm not criticizing ZKP. ZKP is good. ZKP is better for scalability rather than privacy. But TE is good for privacy. That is why I've made up a comparison for this. And why TE? So we have made up a solution, but rather than relying on TEEs for integrity, we are relying on TEEs privacy. So that vulnerability exploit thing for TEEs, that doesn't affect you, because we are not relying on that for integrity, but we are relying on that for privacy. Okay, isolated execution environment. That is where this privacy comes. Okay. And next, how we are achieving this using TEEs, and this line basically is just placeholder. You guys can read this. Yes. So how is this possible? So we have got a bunch of TEEs like Intel SGX, like I said. So we are actually working on a solution using Intel SGX that has basically a secure enclave that allows you to do all this secure computation. Okay, and it's highly compatible with EVM. So basically, you can run your smart contracts in that without much effort. Okay, easily you can do that, and it also includes the roll-up functionality. So whatever transaction you do, that basically gets rolled up. And how this is done? Just a second. Yes, if you want to figure out actually what this magic is, okay, and if you are still confused how this works, then TE-based rollups work in this manner. So I'll just. I guess you guys can't see that. I'll just. Just a second. It's not still visible. That's the only resolution. Okay, that's okay. That's okay. So, on the left corner, you have the code repository. On the right side, on the top, you have auditors, then the governance process, then basically the network, the TE-based network, and then the code validation happens here, and there is something called as attestation. So So what you have to basically do is, if you want to use TEE, then basically you have to attest it. Only if you attest it, then that works. Okay. So any random TEs can't come and can't be a part of this network. Yes. I'll quickly just wind up. Okay. This is the high level design. I can share this with you if you want. So yeah. So one of this I'm a part of this project, so we are actually building this solution called as Obscuro. So we are making privacy accessible to everybody on Ethereum, while scalability and privacy, cost, and all this is ensured. Okay, so without losing your scalability chances or giving more money or user friendliness, you can get privacy and confidentiality of all your data. And if you wish to know more about us, then you can just scan this QR code and read our white paper or light paper and get to know more about this project, and you can start building. So we are right now on a non-persistent testnet, but we'll be out on our testnet very soon. So now you can build privacy-focused dApp smart contracts without much thing. So thank you. Thank you for being attentive and giving me this opportunity. Thanks, ETHTaipei team also.
Thank you, Jobin. Is there anyone have question? Okay, I got a question. So, I think TEE is fantastic, but I was wondering how is the processing rate for the TEE?
How is the?
Processing rate. How?
Processing rate.
Rate. Processing rate.
Rate.
How many transactions could it be processed per second?
So it's basically depends upon our network, but right now what we are building in our solution, we are aiming 40,000 transactions per second, because it's based on hardware and it doesn't rely on a lot of cryptographic complex computation. It's much faster.
Yeah, it's a hardware solution, but it still needs a storage. So you need to go back, write, and read back and forth. So yeah, so I'm not sure how is the bottleneck so far.
So I've shared the high-level design, so you can see how it's made so fast and optimized that you can go right on the execution environment, do the execution, and get back and give the output. And that's why we are able to achieve that 40,000 transactions per second. That's a number we are ambitious about. We are working on that. Okay. That's not the current number we have live, but we are working towards that. But that's the ambition, and we have some theoretical reasons for that.
Okay. Thank you. Thank you for your talk.
Yes, thank you. I think that this is a very new topic for all of you. So you can just go and scan and get to know more. And if you want to reach out to me, you can reach out to me on Twitter on 0xJBA. That's it. Thank you.